Hello, and welcome to another coding session. So this time around I decided to come back to the code I had in the previous session and actually check what the hell is happening with iterators. So last time we figured that the JavaScript code we have on the left is actually performing a task faster than the same code in the same iteration count by a lot. So JavaScript did this accumulator thing of value number 2. So JavaScript did it in 12 milliseconds, and for some reason Rust did it in 93 milliseconds. So I began wondering, is it because of iterator thing? Iterator thing. So the thing is, I mentioned it before, when we work with iterators, every time we check if we have a next item in there. So every iteration of a for loop, we check if something next is there, and we quit it otherwise. So that's fine. Maybe let's see if we can change this for, which works with iterator object, into working with indexes over a array, and see if it gets faster on JavaScript, and then afterwards maybe it would work faster with Rust. So let's maybe jump to it. So I'm gonna delete these. Bam, delete. So let I was using whatever. Let's use I equals 0. Let's make it pretty. 0. I is less than tst lengths, right? And I plus plus. So the item now would be, oh yeah, I want to save it. Okay, const item is now tst of I. Let's see if it works. So it does plus plus. Let's make this prettier. X. Alright, save. Bam. So previously it was 12 milliseconds, and now let's run it. Bam. 11 or 9. What's going on? Alright, so it kind of uses the same amount of time as it was using before. Maybe I shouldn't use const. I don't want to reallocate. I don't want to reallocate it all the time, right? So d word I, let's just go with the silliest version of code that we could possibly have. All right. Also d word I tst I. So we don't allocate every iteration a variable. I mean, again, I'm not trying to make the code less readable. I just want to see what's going on and just get intimate with it, you know? I mean, I love computers, but every computer is a piece of shit, right? So now the code is not allocating a variable every time we go into iteration, and it doesn't have to free a variable every time we go out of an iteration. So that's fine. I guess it should work still, right? Bam. Oh, why is it? The type is undefined. Did I write something incorrect? So I is 0. So this increases. This increases. TST variable type. What? Alright, if there was a person next to me screaming that you wrote something incorrect, or I wrote something incorrect, it would be way easier. But this is actually more fun. So, I'm gonna fail miserably right in front of you. So length, alright, 0. Oh, I've got multiple eyes. Oh shit. See, I wish I had someone next to me. So I'm gonna use something else. I'm gonna use um, yeah, mi main iteration. Okay, it's gonna be a main iteration. I don't care if it's readable for you. I'm gonna care if I can read it this time around. Okay. I mean, this is a test. Nobody writes perfect code immediately, so let's do this. Bam. So it took still 12 milliseconds. Let's run it again. 12, 12, 11, 11. This is actually longer. So we have two accessors. This is two accessors to array item. This is an accessor, and this is an accessor. We access the item, the array item twice over an index. Maybe that's slow, but still, this is way faster than a regular iteration thing in Rust. Well, that's shitty. That's shitty. All right. So right before I decided to record this, I quickly investigated how I would go over like some iteration, and I found that maybe using a while could be better because it doesn't generate a range, would be which would be a iterator as well. So maybe this construct is not what we want. I mean, it could be slower, like by far. I don't know, let's check it out. So I'm gonna copy paste this just to have an outer iterator. So bam, copy paste, bam. I've got a enumerator thing. Maybe let's just work with this first. So I'm gonna substitute this thing because it's being done in more iterations than the outer iterator over TST array. So whoop, there you go. My Vim knowledge is shit. Come on, exit. Alrighty. Um, copy, paste. All right. So let's have this commented out, and I would have similar amount of iterations. So I would yank it here, and I would paste it here, and I would delete that. So now I've got the iterator thing, and I need to increment it just to be able to exit the loop faster. So bam. So I'm going into the loop. I do the math thing that we wanted. We don't have the multiple iterations things in a way. Maybe it's faster. I don't know. We do our math thing. We iterate our enumerator thing. Okay, and I guess I need to set it to 0 here. So this is a 0 here, and maybe it's a good idea to reset it to 0 again here because we're going into it in iteration. So this is not perfect, but still we are able to preserve the same functionality. So we are at 0, the n is 0, then 1000, we do something, we iterate, then we go. Then once this is done, we still get back to the iterator thing here, and from 0 to whatever million, how much is that? Yeah, I guess it's a million. 3 and another 3, yeah, it's a million. So another million iterations can run. Okay. Oh my god, I hope it doesn't crash. Yes! So, oh, it ran for 9 milliseconds. So, range generation in Rust is slow. Wait, hold on. So the result is the same. The result is the same. But the time it took to run jumped from 93 milliseconds to 9, almost 10 milliseconds. Whoa. Amazing. So apparently for small data sets, the range generation for small data sets, the range allocation is okay, but for these numbers, I wonder what a range is. It's a structure or an array which has a specified amount of elements, in this case a million. So it would be another array, right? Which would have another iteration thing. And every item in the array would have a next pointer just to be able to know if there is a next item for the loop to know if it should continue. This is mind-boggling. So just by removing the freaking range, I was able to have the best result I had in JavaScript in Rust by just applying correct data structure and whatever. So again, this test is nothing on its own, but it teaches a lot. I'm amazed. But this thing here, I wasn't sure if this is actually slow, right? I mean, yeah, it does create a iterator, but it only has 2 items. It only has 2 items over here. So it's not as slow as the range generation thing over here. I just wonder if all the Python guys, the guys that are using Python for data science and are relying on the range functionality for their loops, are they getting the same slowness? I mean, to be fair, 80 milliseconds or 9 is not that much, but my data range is really ridiculously slow. I was previously going to use arrays, like array access for the vector, but apparently it's not even that much of a deal. The problem was iterating over multiple items in range 4 loop, and every item would be checking the next element just to know if a loop should continue or not continue. This is another revelation I had just now. I learned it right in front of you. Well, maybe it's a bad idea to use ranges whatsoever, but they are freaking easy to use. I mean, in the tests I had previously, I mean, this is generating a range. Well, let's remove a bunch. From 0 to 10, not including, and if we wanted to have a range with 10 including, I would just write this. So this is a range of 0 to 10 including. This is so easy, and it's straight out of Python. I think it's almost the same as in Python. So easy to use and so slow to execute. Oh my god. So let's go back maybe and yank it like a copy and place it back over here. Let me do this. B. Oh crap. I suck at Vim, but I like it. It's like with Rust. You fail a lot, but you love it. Come on. Why is it not copying? See, although I am getting some really good insight with you, I'm still failing a lot. Oh, I don't need to use this. Ah, oh, stupid me. I just gonna remove this. Bam. So, for future generations and myself included, maybe it's a bad idea to use ranges for high amounts of computations that you are doing. Stick with standard whiles and your own managed indexes or limits, like in C or other languages. Oh my god, that's interesting. Another insight for today. Amazing. Thank you guys. I hope you liked it. This is really going deep into what programming is. It's not about solving problems that you know people have like the faster delivery or whatever. It's about being a true nerd and finding how it actually works. How can you do this for a living if you're not interested in how it actually works? All right. I guess I will see you in another session. Bye.